This is a review of section 7.1, which was graphing exponential models, and also a quick problem applying exponential growth. So the first one says graph y equals 3 to the x plus 2, and remind yourself that this exam is entirely with the use of your graphing calculator, so probably the easiest thing to do is to go to your y equals and type in this equation. And then, of course, once you do that, you can go to just a standard window and take a look at it. You can also go to your table and just fill in this table using your table from your calculator. If you test points, and things you'll still want to familiarize yourself with is that it has a plus 2, which is going to be a vertical shift, and that's going to be up 2, and there is no horizontal shift because that would be something that would be added or subtracted to the exponent, and there's nothing. So when you did this before without your graphing calculator, you just tested some points. You kind of ignored this shift of plus 2. So if we ignore the plus 2, and I might test just like 1, well, 1 would be an easy point to test, 2 would, 0, maybe -1, so I'll start with -1. This should be enough. And I'm just going to test y equals 3 to the x and ignore the plus 2 and then shift after. So if I do 3 to the -1, that's going to be the reciprocal, so 1/3. 3 to the 0 is 1. 3 to the first is 3, and 3 squared is 9. And then I'm going to take all of those y values and shift them up 2. So it's really going to be 2 1/3, 3, 5, and 11. I'm just going to kind of cross those out so I don't accidentally use those. And then, of course, if you graph those on your calculator, and I guess on this graph, I think my graph is going to be too small, but your vertical shift is your asymptote, so that at 2 is going to be a horizontal asymptote, so make sure you draw that in, and then you can just plot your points, so -1, and then like 2 1/3, 0, 3, 1 and 5, and 2 and 11, which would be off my graph, so you can kind of tell that it's going to be that way. Now remember, when you look at this on your calculator also, sometimes it looks as if it just kind of stops, and it doesn't. It goes on forever. So include those arrows. And then your asymptote is drawn in, but that's always your vertical shift, so that's y equals 2, and you can see that your domain is always all real numbers with exponential functions, and my range is all real numbers that are greater than 2. So y is greater than 2. The second graph, I'm going to go through this one kind of quickly, has a horizontal shift to the left 2, and if you note that plus 2 is going to really, that's your h, which shifts you the opposite of what it appears to be. You have no vertical shift, so my asymptote, I'll fill this in right away, is going to be y equals 0 because I don't have a vertical shift. And I would, again, just test points y equals -2 to the x. And you can dump this in your calculator, of course, and not have to worry about what I'm, about to walk through necessarily, and just dump it in your graph and get some points from your table. So I'm going to just graph probably, again, -1, 0, 1, and 2 are good. So -2, and be careful with the negative, -2 to the -1 is really negative, and then you reciprocal 2, so -1/2. Anything to the 0 is 1. But it will be negative still, sorry, because this is really like a negative times 2 to the x. And then 2 to the first is 2, but then it's negated, so that's going to be -2. And then 2 squared is 4, but then it's negated, so it's really -4. If, by the way, this -2 was in parentheses, then this would be a different story, but it's not. So it's like that negative is just negating everything that you get in the end, so be careful with that. And of course, if you type it on your calculator as is, you'll be fine. And then all of those points are going to shift to the left too. So again, what I'm going to do is I'm just going to change my x values to go to the left too. So it's really going to be -3, -2, -1, and 0. And then I'm going to kind of just cross through those. And then I'll graph those. So -3 and then about a half, and then -2, -1, -1, -2, and 0, -4. And you can see that that's a reflection of a growth function. Domain, again, all real numbers, and range here is all real numbers that are less than 0, because the graph is all below 0. The last problem here says Katie deposits $4,500 into an account that earns 5.25% annual interest, compounded monthly. Find the balance after 3 years. All right, so this is a compounding interest problem, and she's going to deposit this one time. And that's really critical because on the exam, there's going to be problems just like this that might say she deposits $4,500 every month or every or quarterly or something that's periodic, and that would be an annuity formula. So if it's just a one-time deposit, remember you have your little formula sheet. You're going to use this compound interest formula. So I'm depositing $4,500. I'm just going to fill in the numbers. So that's your P, your principal deposit. Your interest rate is 5.25, but remember to write that as a decimal, so move it to the left 2 places. N is how many times you compound it. So if you're compounding monthly, that's 12. And then N times T, you're doing this for 3 years. So there would be your setup. Then obviously grab your calculator, and I would personally just type this in step by step, but you certainly can, push pause and see if you can get the answer. But I would start right here on my calculator, and I'm literally going to do this right now, and divide that out, and then add 1. And I'm going to write out a few steps. You certainly can just show the setup and then the answer, but make sure that you're real careful. So this is 1.004375. Do not round anything until the very, very last step. When you're writing it down, it's fine, but don't round your final answer to the end. And then I'm going to raise that to the 36th power, and then, last but not least, multiply by 4,500. And you should get $5,265.80, and that makes sense.